Good morning, ladies and gentlemen. Welcome to Good Burger, home of the Good Burger. Can I take your order? In section 4.3, we're going to be writing and solving addition and subtraction equations. And so we're actually going to be figuring out what the variable is worth that would make a situation true. Okay. And so some vocabulary here, right? To solve equations, you are going to use inverse operations. Remember, inverse operations, let's use a different color, are operations that are opposites of each other. Right. Essentially, inverse operations are operations that will undo each other. And so there are two pairs that we're going to think about. Adding and subtracting will undo each other. Right? If I add 5, and then I take 5 back away, right, I have the same thing that I started with. If I multiply something by 2, and then I divide that same thing by 2, that's the other one. Right? Those operations would undo each other. And so we can use what we learned in the last section about properties of equality, where I'm doing the same thing to either side of the equation, as well as these inverse relationships to solve equations. And that's what we're going to do today. All right. So first we're going to look at an addition equation. And I don't expect everyone to draw pictures, but I do want you to be aware of what these pictures are saying. So in this particular situation, right, this is an addition picture. Okay. And so, that's weird, this should say C. That says C. Okay, so we're going to draw a bar diagram to represent, and then we're going to solve. So, I have this equation, 5 plus C equals 15, right? 5 plus C, and then this whole bar up here, if I put all this together, it equals 15. So immediately, some of you are going, well, what plus 5 equals 15? And you probably already know the value for C. Okay, I totally get that. I need you to kind of bear with me because there's a process here that I need you to learn when the problems are this simple. Okay? Oops, well, technical difficulty here. So the general idea here, right, is that if I'm asking myself what plus 5 equals 15, right, I can use an inverse operation here to kind of solve this equation, right? The goal is to get C all by itself. So in order to do that, I have to deal with this positive 5. To undo positive 5, remember that the operations that are opposites are addition and subtraction. I can subtract 5 from over here. Right? I can take that 5 away. But the only way I can do that is if I also take 5 away from the other side, right? Remember those properties of equality, right? This is still going to be equal as long as I subtract the same thing from both sides of my equation, right? If I only subtract 5 from one side, well, now I've changed the value of the equation. But if I subtract 5 from both sides, right? 5 minus 5 cancels out. I'm left with C. 15 minus 5 is 10. Okay? Now, how do you know that that's right, Mr. Heckman? Well, that's a good question. Right? You can use substitution to kind of check this out, right? By substituting in 10 for C, because that's what we think it is. And so if you think 5 plus 10 is equal to 15, then we know that this is a correct answer. If you didn't understand what I just showed you, I want you to pause, and I want you to come and see me. If you are thinking you're on the right track, let's talk about another example. Right? In this case, n plus 7 equals 25. Again, I know most of you are already going, what plus 7 is 25, and you already have an idea. What we want to practice here is how can I use inverse operations to get n all by itself. we want to solve for the variable. And so to do that, to end up with just n over here, I need to get rid of this plus 7. And to get rid of plus 7, we have to subtract 7. And if I subtract 7 from one side, now I'm out of balance. I also have to subtract 7 on the other side. And this is the way I want you to write these problems when you're doing this work. Right? So 7 minus 7 cancels out. I'm left with n. 25 minus 7 is 18. I think n might be 18. Why don't you check with substitution, right? So I would substitute in my value for n. Is that a true statement? Yes, 18 plus 7 is 25, so n in this situation equals 18. Right? You try this example on your own. Again, notice that we are using the inverse operations of addition and subtraction, and I am using the subtraction property of equality here by subtracting the same thing from both sides. And so when I do 24 minus 24, those cancel out, and I'm left with just n, and 49 minus 24 is 25. And I checked right over there. Right. Let's look at some subtraction ones. Right? Same idea here. Same idea here. Right? So when you draw a picture of subtraction, it's kind of tricky, but you're really actually just drawing an addition expression, right? Because 20 plus 16 is going to get you this whole bar right here. And then if you kind of go back and think about it, right, if I take the total that I have and I subtract one thing, I'm going to end up with the other side. Okay? The general idea here, right, again, we're looking at just addition and subtraction. So, you want to get the variable all by itself. So how would you undo subtracting 20? Right? The opposite of subtracting 20 is adding 20. And if I add 20 to one side, I have to add 20 to the other side. So minus 20 plus 20 gets me 0. I'm left with m. 16 plus 20 equals 36. We could check that. 36 minus 20, right? I plugged in 36 for my variable. What is 36 minus 20? Well, that would be 16. So that's going to give me my answer. If you're feeling comfortable, pause and try these two on your own. Remember, though, that I do want to see the work that I've been showing in the other equations we've solved so far. Otherwise, continue to watch along. Right? Again, when I see subtraction or addition, I know that those are my inverse operation choices. So y minus 19 equals 34. How do I get rid of minus 19? I add 19. If I add 19 to one side, I have to add 19 to the other. Minus 19 and positive 19 cancel. Leaves me with y. 34 plus 19, let's see here, 34 plus 10 is 44, plus 9 is 53. So we go back and check. I plug in 53 for y. So that's 4. And that equals 34. That's a true statement. So y must equal 53. Okay. Again, pause and try it by yourself, or watch along with me. To get rid of a minus 19, I add 19. minus 19 plus 19 cancels. I'm left with S. 32 plus 19 is 51. This is suspiciously similar to the last problem, right? What is 51 minus 19? That is 32. That's a true statement. Here are a bunch of examples. I would invite you to pause and try these on your own. There are my 6 problems. Notice in these top three, those were all addition equations. They all had, the only operation was addition, so I solved those with subtraction. And then down here, these were all subtraction, and so the inverse operation there is addition. Again, in each one, I showed the step that I was doing, I showed what was left over, and then I also checked to make sure that my variable was correct. That is the amount of work I should see when you're solving one-step equations. And then some situations can be solved using either operation. So we're going to just look really quickly here at one. I'm not going to show you how to solve it. You can solve it if you prefer. I just want you to be aware that you could technically write some situations using addition or subtraction. So Andy had some cards. After he bought 12 more, he had 48. So how many cards did he have at the start? So what we could write here, is I have however many cards he bought plus 12 equals 48. So however many cards he had plus the cards he bought equals his new cards. I could also write, the cards he had, the cards he has minus the cards he started with is equal to the cards he bought. Okay. Either one of those would get you a correct answer. So you can solve those and figure out how many cards he started with using either of those. Again, please see me with any questions. This is a foundation for things that are going to be coming for the rest of the year. So this is important to get down. Complete 4-3 and have a great day.